Now let's have a look at 2006, question 1, part A. This is a multi-stage linear velocity question. So, in part 1, they want a speed distance time diagram. Alright, well, we know our little lift starts from rest, it goes down. Now don't get thrown by the fact it's going down, because we're only dealing with speed here, not velocity, and overall distance travelled. So we are going to have our speed time graph. There's speed, there's time. Okay, time and speed. It starts at 0. It goes with uniform accelerations, so straight line, f. And then it decelerates at 3f, so a steeper line. There it is. That's a speed time graph. Oh, sorry, total time, t. Part 1 done. Now, for part 2, it's worth remembering a few little facts in this one. When we have this kind of graph here, we'll split it up here into 2 sections. First section, second section. Acceleration of the first section over the acceleration of the second section is the time of the second section over the time of the first. This is our little thing that we know from our fabulous study and preparation. So let's use that here. F over 3f equals, we haven't really got these numbers yet, so let's give them some names. We will call that T1 and T2. Okay, T1 is the time from there to there, T2 from there to there. T2 over T1. Simplify, cross these guys out. So that is 1 over 3. Bring T1 up there, bring the 3 up here, and we end up with T1 equals 3T2. Now, what you can see in this one is that this bit here is 3 T2s, and that's 1 T2. So we have 4 T2s altogether. All right. So T equals 3 T2 plus T2 is 4 T2. Okay, which means that T1, all right, T1 is going to be, let's come back here for a second, 4 T2. For T2 is a quarter of T. All right, which means T1 is 3 over 4 T. So now we know this little point here is 3 over 4 T. That's going to be useful for us. Okay, part 2. Distance. With loads of these questions, you can use the fact that the distance is represented by the total area under the graph. All right, that's going to be the key to a whole lot of these things. Now that equals half the base, which is t, by the total height, which we are going to call v, because it's going to be our maximum speed. Half tv. All right, that's fantastic, except the fact that we don't have v. So let's make a little space over here. We're going to find v. Turns out this isn't too hard, because it's just the maximum velocity. To do this, we're going to look at just the first section of the graph. We can use the second section either, but there's no need to make our lives hard and use both. So, looking at just the first section, we use v equals u plus at. It's a nice easy one. In our case, u is 0, a is f, and t, be careful here, t is just 3/4 the total time used. All right, so that equals 3 over 4 ft. Now, let's take this guy and bring it back here. Sub in v. So d equals a half t times 3 over 4 ft. A little bit of housekeeping, and d equals 3 over 8 ft squared. There we go. D in terms of f and t. All done.